Okay. One of the big questions I usually get with people working with base geometry is that sometimes the geometry play a role of how your final paneling looks like. Let's now use some base geometry. Let's create a simple plane here. And let's say I want to distribute my grid on that surface, on that plane or surface or what have you. So as I mentioned, paneling tools provide options to divide or generate grids using some base geometry. One of them is, one very popular one is using surfaces. So I can select an option or a command that generates the grid by dividing the domain of my surface. Dividing the domain implies that the underlying parameterization of your surface is going to be used. If you are familiar with the idea that nerved surfaces, which is what's the main geometry used in Rhino, have a U direction. I usually show it these ISO curves called in the middle, red in the U direction and in green in the V direction, so I can quickly recognize the directionality of my surface. And that parameterization might not be as even and uniform as you might think it be, depending on the way you create your surface. I'm mentioning that because this will have an effect on your final result. And this, by default, when you create a simple plane, it's very evenly kind of divided. If you follow the domain of your surface, you'll see that you can change the number of spans, but you see that they are separated almost evenly in between, within that plane surface that I'm using. So I'm still in preview mode, and you can tell because I'm showing the arrows in the U and V direction of my grid. I press enter. That means I commit my my grid, and now I have a grid generated on top of that surface. I will just hide the UV directions to improve the visibility for you. Now, once I created my my grid, I can go ahead and use the panel as we did in the previous section and say, okay, I want to create those. I can select the surface as base for me, and I can change the pattern to whatever I want it to be with the output I desire, and then I'll just stick with edges for now. Usually it's a good idea to stick with edges or meshes when you are just developing the concept. Because adding the faces is much bigger overhead and calculation time to generate the faces, especially on top of a free-form kind of surfaces. So I press enter, and then this is my panels. These are my curves already generated. And you see how that is looking. If I had another what appears to be a similar or identical plane, and I'm just going to rebuild it. There is the rebuild command in Rhino that enables you to increase the density in U and V direction. Basically, you'll have more points to manipulate, and then beyond that's showing me the underlying structure of my surface. I'm just going to drag it around a little bit just to manipulate my parameterization of my surface, and you'll see that I made it more dense towards the ends than the middle. But the surface actually, or the plane, looks very similar to the one we just worked with. But if we actually call the command again to divide the domain by number, you'll see that the points are denser towards the ends than they are towards the middle. And that's really following the way I dragged and manipulated my underlying surface. So sometimes you get a result that you think it's not consistent with what you're looking for, and sometimes it's very hard to kind of reconstruct your surface to have even distances. In this case, maybe this is the kind of effect you're looking for, but in other cases, that's probably undesirable situation. So you see how my panelings now are following that outline or that parameter space. So basically, how the grid now is looking. Even worse in some cases, let me copy that plane again here. And you might find yourself working with trimmed surfaces. So I'm just going to create a trimmed surface. What I did is I extracted the border of my original plane, I scaled it, and then I'm going to use a trim command. Many times you are presented with these surfaces rather than create them from scratch. Actually, if you create them from scratch, then you have control over their parameterization to some extent. But if you find yourself presented from designer or other sources by that plane, what looks identical to the one we just worked with, this one, but if we try to create the let me just move that a little bit out of the way to give you a better view of it. Now if I try to go ahead and create the grid, you'll see the grids actually follow the underlying surface, the full surface that you have. And you can choose to trim the grid in the end, but sometimes it's better to work with a bigger grid with a trimmed surface so that you can trim your panels to the edges. So if I press Enter, accept it, and go ahead and panel it, look what happens. I get all the paneling all around. Actually, I'll repeat that command so I select the base surface so I can trim against it. That's one of the great features in paneling tools is actually you can trim your paneling to the edges of trimmed surface with especially with 2D grids. It's very successful. So you select your grid points, and in this case I'm going to choose that base surface as my base. And then that's the diamond. You can pull your panels and all that and press Enter, and you'll see how all these additional or extra panels or lines were trimmed to the edges of that surface. So you'll end up with panels that are within that surface. But that will create an effect that is very, very different than the first two examples we just showed. And on the surface, it looks like the three surfaces, the three planes, were identical, but they weren't because of their base, because of their parameterization and because of trimming. So you need to be aware of that situation and be able to kind of manipulate or work with your grids to be able to use that surface successfully.